Hello, I'm going to be making two types of projectiles, a straight moving projectile and a projectile afflicted by gravity. I'll be going over raycasting, but I expect you to know how to do some basic tween surface already for this tutorial. Alright, now I'm going to begin. First, we're going to start with basics. I'm going to be making this block be the projectile, and it's going to hit into this wall. And the first thing I'm going to do is, first you want to add a script. Oh, this is the wrong part. First, you want to add a script, and then make a module script under server script storage. I'm going to briefly explain what a module script does. So that's the wrong module, this one. So what you can do with a module script is they give you this table, and if you put a function into this table, a script from or other scripts can use it by using this require. You put in your module script in here, and now you can access the function that you put inside here, allowing you to effectively make a single function be able to be used by all other scripts. One thing before I start explaining what the function does, so let me just overview. So I pass in the part that's going to be used as for the projectile, the speed that I want it to go higher obviously means faster, and then the destination, because I need a destination for tween surface to work. Now, before I get into this function, the parameters has this thing right here, a colon. What this allows you to do is, it doesn't actually change anything in the script. It allows me to, usually when you access a parameter, it doesn't show you anything because it doesn't know what it is, but putting this colon means you the script editor expects this to be a part and gives you all the properties and all the stuff that comes along with the part. And see, speed I didn't give speed any, and so it doesn't have any of the properties because the script editor expects speed to be anything, so it doesn't show anything. Alright, the first step is creating the tween, and I'm gonna run this real quick right here to show that the projectile is now moving because of tween. Now, the first thing you want to do is controlling the projectile speed, and you do this by getting the end goal and the current part's position, getting the distance between them, which you can get with this equation right here, which is dot magnitude basically gets the distance of a vector tree, and then you get the distance and then divide it by your speed. The speed is just a single number. I put 2.5. The higher it is, the faster the projectile. And then I put it in all inside of this tween info, and that completes the tween thing. I've coded in the collision detecting portion of the script, and if you can see here, it will stop on the wall. And if I shift the wall further away, it will keep going until it reaches the wall, and then it will stop. Now, I'll start by explaining the while loop I entered here, and this while loop basically just checks over and over whether there's a collision. Now, for this part, using the track, there's a property called playback state, and I want to make sure that this while loop only plays when the project track is currently running, and you can get that using enum.playbackstate.playing. And if you're confused what this enum stuff is, I'm pretty sure you've seen it before. What it does is enums basically store different types of variables, because when you get a playback state, the playback state is called playing, but I'm pretty sure if you put in a string here called playing, it doesn't match up with what this property wants. It's like trying to put in a single number into size property. It won't accept that. It will just convert it back to vector 3. So it wants a specific data type that is stored in this thing called enum. Now for the function or the contents of the while loop. So I want to check around every frame, so 0.016 seconds, and I put in a direction here. And just quick note of what this, if you put two vectors together when you're making a new C frame, it makes the first vector is to determine the position, and the second vector 3 is, let's say I give this position into the second argument, it will make this position face toward that vector 3 and give it an orientation based off that information. So I do that will give me the direction. Then I put dot look vector, which will give me the direction in vector 3 of vector 3 direction, and that is needed for the raycast. And basically, it's a vector 3 of, say, if I added that vector 3 to this part, it would be pointing that way. The vector 3 would shoot out this way. Now, now that I have that, I get the distance, and I create the shapecast. The shapecast is basically a raycast, but you can use a part instead. So I put in the part, and then I put in the distance and the direction. There's also parameters, but we don't need that right now. And if the collision isn't nil, that means the raycast did hit something. I'll pause the tween track, which will stop its movement, and then end the function. So this is a little confusing, but basically, a shapecast, what it does is, given a vector 3 direction, it will move that part in that direction. So say, you see how this says 0.1 here? That means the direction vector is 0.1 in the z axis, because blue is z, I'm pretty sure. So that means the direction axis, that means if I put a vector 3 of 0, 0, 0.1, it will move it 0.1 in the z axis, and If it doesn't collide with any part, that means it will return nil. The shapecast will return nil. If yes, then it will run this thing, end the function, and stop the projectile movement, and allow the main script to do whatever it wants after it has collided with something. Small oversight, my bad. While I was editing, I just realized you should tween it by C-frame. So when you make your tween track, turn it to C-frame, and convert your goal into a vector 3, or convert your vector 3 parameter into a C-frame by doing C-frame.new, put your goal inside, which convert it into a vector 3. And since a C-frame is both orientation and position, you also need to add on the part's rotation too, because we don't want to reset the part's rotation if it's orientated. Now let's look at the cool projectile script I made, or the cool script I made for the orb. And these 3 functions are all purely aesthetic. I replaced the old module script function I used with the one I made for this video, and it works just as fine. I'll test it right now to show you guys. And really, the only difference between this and the cube is that I'm using a model to shoot the projectile. See, it still functions completely fine. Though you might need to use raycast parameters, because you can hit yourself with this move, and it won't do damage to you, but it's annoying if it just clips straight into yourself. So that's why you want to learn how to use raycast parameters. But other than this, everything else is all aesthetic. See here, I'm just changing a what's called a particle emitter to different rates. This one is just moving it. This charge up script is just I just put in a module for some reason. I don't know why I did that. This is the wind up animation where all the energy forms into the orb. This one I just used tween to make the orb bigger so it looks like it's getting more power. Basically, once you have the module script, you can use it for everything. So let's look at another example I used this module script for. If I go into here and I get this stone spike barrage move is also using a projectiles module. So if I use this, it will shoot out stone spikes, and this is using the same exact thing as, or not the same exact function because I didn't change this one, but if I could change it to the one that's being used by energy orb, it'll still work exactly fine. And that's why putting this into a module script is so versatile, very useful. Now we're going to tackle projectiles with gravity, and you can see here it works perfectly. And how this thing works is we're going to be using run service instead of a loop this time. I'm not going to explain too much about run service, just know it's a very fast loop. It runs on an event, it just fires the event very quickly. And it also conveniently gives you a delta time, which is how what's called the delay between each event fire, which is basically a very accurate loop that's somewhat inconsistent. No, it's not very inconsistent. If you run on the server, that is. So every time, just treat it as a loop. Every time this function fires from heartbeat, that's a loop. And delta is basically the wait time we use. So every time it fires, we're basically trying to change the position of the part or to where it would be in that amount of time it passed. And velocity's formal name is change in position. So when we pass in our velocity, which is a vector 3, we're not using speed, we're using velocity. It will basically say if a part is moving two studs per second up after 2 seconds, how far would it go? It would move up 4 studs. So delta is our time. Delta is usually like 0.001 seconds. So in 0.001 seconds, where would the part's position be if the velocity is, how much did I pass through? 25 in the direction that the part's facing. It would probably be a very low number. That's why we have the super fast loop. And then for gravity to work, we also change the velocity, which is just causing a huge chain reaction. And we want the velocity to go down because gravity makes parts move down, right? They make projectiles move down. So we change velocity where gravity will decrease the velocity's y value. So if we shoot a projectile up by like 25 studs per second, the gravity will change that velocity to like 24, 20, 14, and then eventually -6. And if it's -6, that means the projectile will start moving down. And that's how this physics works. I try to explain the best I can in simple terms. And then now we have our raycast. The raycast just uses velocity instead of direction, since velocity is already a direction vector. And then if there's a raycast, it will just stop the loop and return the raycast result. Before the video ends, I'm going to quickly brief you on how to make this acid shot ability, because this one's pretty simple outside of the hitboxes and stuff, which I will not cover. So the move itself, the cooldown, I need to talk about the cooldown first. So first it checks if the cooldown is above 0 or is at 0, and then if it is, it sets the cooldown to whatever number you want, and then here's the cooldown script. So while the cooldown is above 0, it will wait 0.1 second and then reduce the cooldown. Oops. This script right here, this just changes the name to whatever the cooldown number is and all this fancy stuff. It's just to make the name look nice. So that's how the cooldown works. It reduces it. I use task.spawn. What this does, if you want some task.spawn, you put a function in here and it makes this function if the function like has a wait statement inside, it will install the rest of your script. Now onto the move. So we have here player.mouse. I should probably explain how this mouse script works. So the mouse script, I call a module called get mouse, and this thing let me go find it real quick. All right, here we go. So get mouse right here. What it does is if it invokes what's called an object called remote function, and this remote function is connected to the local script return mouse. This is very similar to a remote event. So you get your thing, you get your get mouse, invoke client, it will go here. This is the target. So it has get mouse here. On client invoke, it will call this function. You have to put an equal sign into the function. I don't know why it's like that. And this will create a table with all the mouse properties inside. And that's how I get all the mouse information. So the important things to make this work is you gotta use game.replicatedStorage.getMouse invoke client, and then with that same remote function, go here. Oh, not here. Go here. Get mouse on client invoke, and this will return all the client information that you want. And it all loops all the way back to this script, and I get the mouse information. And that's pretty poorly explained, but the ACID spit is not the main point of this video. So the reason I want this is because the velocity I want is where the mouse is. So all of this is just cool effects. For this thing to work, I have my acid projectile right here. Yes, I clone this, move this in front of the dummy, apply my projectile motion so it flies up and hits the ground, and then it splatters. I just tween it and flatten it with this 20v4 v20. It will flatten the goo, and since this is a mesh, the spheres can flatten. And then I activate my little tiny circle particle emitter to make it look cooler. And that's basically how the acid spit works. Yeah, I think that should be the end of the video. If you want a fully in detail version like I did with my how to make abilities video on how to make some of the abilities I showed in this video, I would, but it takes those videos take a lot of effort, and right now my channel's kind of dead, so I don't see a point in doing it right now. So if this video does really well, I'll make an in-depth tutorial on how to make the acid shot ability. All right, goodbye.